Now we are seeing a problem from the topic principal stresses and strains. Let us see the problem. A small block is 4 centimeter long, 3 centimeter high and 0.5 centimeter thick. It is subjected to uniformly distributed tensile forces of resultants 1200 newtons and 500 newtons as shown in the figure. Compute the normal and shear stresses developed along the diagonal AB. So along the diagonal AB means on the diagonal AB we have to find out normal and shear stresses on this diagonal AB. And here is the diagram shown here. Is a member subjected to forces like this is given 1200 newtons and 500 newtons. So let us take this as x direction is y direction. So this is the resultant force acting in this x direction, that is 1200 newtons, and this is the force that is resultant force is given acting in the y direction along the y axis 500 newtons, and the diagonal AB is on this diagonal we have to find out normal and shear stresses, and this diagonal is making angle of theta with this plane, that is a normal cross section. And here dimensions are given like 4 centimeter length, height is 3 and width is 0.5. This is centimeters and this is theta. And in this case we are supposed to find out as I told already normal and shear stresses on this oblique plane. So to solve this question we have the formulas of normal and shear stresses on the oblique plane, and this comes under the case number 2, that is a member is subjected to two mutual perpendicular stresses in two mutual perpendicular directions. For that we have on the oblique plane we have normal and shear stresses formulas, that is in terms of sigma x and sigma y. If you take this is sigma x and this is sigma y, we have sigma n formula, normal stress formula, and shear stress formula. We'll substitute in that formulas and we'll find out normal stresses on this oblique plane. So the force is given here. We'll find out the stresses in this x and y directions, and after that we'll find out normal and shear stresses on this oblique plane. So before that, if you are new to my channel, please subscribe to my channel and activate bell symbol, and also please share my videos with your friends. And see, if you see here, we have seen already, we are seeing here the given data. Length of the member is given 4 centimeters, height 3 centimeters, and width we have seen it is 0.5 centimeters. And if you see, we have assumed this is the x direction and force in x direction 1200 newtons, force along or in the y direction 500 newtons. So here I told to find out normal and shear stresses on this oblique plane. That's our final aim. We have to find out stress in x direction and y direction, sigma x and sigma y. Why? Because the formulas of normal and shear stresses on the oblique plane will containing sigma x and sigma y and cos theta or theta. So here we have to find out sigma x and sigma y and theta values, and here also the shear stress formula also containing sigma x, sigma y and theta. So for that reason we are supposed to find out stress in x and y direction and this theta value. So for that we know stress is load or force by area. So area means we have to take here the normal area which is perpendicular or normal to the force direction. So this is sigma x, x direction, so sigma x, and this is sigma y will get. So this area perpendicular or normal area we have to take, and this area we have to take. So that is nothing but 3 into 0.5 and for x direction, and 4 into 0.5 for y direction. So this is 0.5 means 0 is also 0.5 centimeters. This is also 0.5 centimeters. So for that here we are finding out area of cross section normal to x axis. If you see, so area of cross section normal to x axis, means this area, that is 0.5 into this 3 or 3 into 0.5, that is 3 into 0.5 1.5 centimeter square, and area of cross section normal to y axis. If you see this area, that is 4 into 0.5, 4 into 0.5, it is 2 centimeters square. So we know we are calculating sigma x here. So stress along x direction sigma x, that is we know simple stress formula, force by area or load by area. So here force in the x direction is 1200 newtons, and area normal to x axis is 1.5 we got here. So when you simplify that, we are getting sigma x as 800 Newton per centimeter square. and also we require stress along y direction or y axis. Sigma y is nothing but force along y axis by area normal to y axis. So force along y axis is given 500, area normal to y axis, this area we got 2 centimeters square. When you substitute there 500 by 2, we are getting sigma y, that is stress in y direction, as 250 Newton per centimeter square. Here I told we are supposed to find out theta also here. So this is the theta given in the question, and if you observe this triangle ACB, so from this triangle we can write tan theta is equals to opposite, that is 4 centimeter by adjacent 3 centimeters we can write. So that here we have written tan theta is equals to 4 by 3, theta is equals to tan inverse of 4 by 3, and we are getting theta value as 53.06 degrees. So when you just substitute in those formulas, so we require normal and shear stresses on the diagonal AB we require here. So we are supposed to calculate normal and shear stresses on this diagonal AB. So here we are taking sigma n is the normal stress on the diagonal AB, and sigma t is the shear stress on diagonal AB. And for normal and shear stresses for this case, when the member is subjected to two mutual perpendicular stresses, so we have this formula. This is sigma n formula, and this is sigma t formula. So friends, for this explanation of for this formulas or derivation of for this sigma n and sigma t formulas, please refer my previous video on principal stresses and strains, that is case number 2. So anyway, we have sigma n formula as sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta. Sigma x we got stress in x direction 800, sigma y 250. You see here sigma x we got 800 and sigma y we got 250, and area perpendicular to x we got 1.5, and this we got area is not required, sigma x sigma y is required. So sigma x 800, sigma y 250, and substituting these values and theta value we got 53.06. so 2 theta is there, so 2 into 53.06, when you substitute there it is cos of 106.12 and it is minus 0.2726. So when you simplify that, we are getting normal stress sigma n as 448.65 Newton per centimeter square. So normal stress on the diagonal AB, and if you see shear stress on the along the diagonal AB, that is our tangential stress sigma t is given by the formula sigma x minus sigma y by 2 sine 2 theta. So sigma x we got 800 and sigma y 250, and sine 2 into theta value 53.06 we got. So when you substitute this value, and it is sine of 106.12, it's a 0.96 is the value for this, and it is 275 for this first step. And if you simplify that, we are getting sigma t tangential or shear stress on the diagonal AB as 264.18 Newton per centimeter square. So this is a way to solve this kind of question, and for more videos don't forget to subscribe and activate bell symbol, and also please share my videos with your friends. Thanks for watching.